23, this is a perfect example of a Pythagorean substitution. You see how it has sine and cosine squared, not double angle. And the sine's saying, I'm not going anywhere because there's nothing you can change me to. Well, yeah, you can change me to 1 over cosecant, but then I'm going to make your life even more miserable. So u cosine squared has to go. So what do I write instead of cosine squared? I write its sine equivalent, which is 1 minus sine squared x. This is not on your reference sheet. You have to have this memorized, the Pythagorean identities, which we gave in a different topic review. Notice that the 2 did not get blocked out. You have to distribute that 2 out. Now, you could do the let statement if you like. I let x equal sine x, and I can make the sine squared x as x squared, etc. Distribute that 2, combine like terms, and set it equal to 0. These are my coefficients, my -2, my 3, and my -1. I put it into my quadratic formula. Remember the suggestions to square the b yourself. To put this into the calculator is one shot. Your discriminant in the calculator is 1. Square root of 1 is 1. If that was a non-perfect square, we would just keep the radical and it would be a decimal. It's not a big deal. Say that was a 2, you would be -3 plus radical 2 all over -4. -3 minus radical 2 over -4. And then you use your calculator face for decimals. Here it's nice. It's a nice rational value, which means this was factorable. So I get my 1/2 and my +1, because -4 over -4 is 1. Now I bring back the trig, which happened to have been sine. This is my sine x equal 1/2, which is a first degree QRA like we've done, positive in the first and the second quadrants. Reference angle is 30. The angle answers in the first quadrant is 30, in the second quadrant is 150, which is 180 minus 30. In the second branch here, this is a quadrantal situation. When you have sine or cosine equal to 0, 1, or -1, we go to the graph. You can either draw out the graph or you can draw out the unit circle. This is my unit circle where the radius is 1. These 4 intersection points are the coordinates 1, 0, 0, 1, -1, 0, and 0, -1. Every coordinate on the unit circle is represented trigonometrically as cosine, sine. So where is sine 1? Well, this is where sine is 1 right here, which happens to be at 90 degrees. So what are my 3 answers? 30, 150, and 90. It doesn't have to be rewritten in any order. Any order is fine. And there you go.